Welcome back to the lecture series on digital signal processing. This is the second video in the following series. If you have not watched the introduction video, you can click here to watch it. Today in this video, we are going to see the discrete Fourier transform and inverse discrete Fourier transform. Before starting the video, subscribe to the channel and like the video. Let's get started. First, we will see what a discrete Fourier transform is. Discrete Fourier transform is defined only for the sequences with finite length. That means it is applicable only for the finite duration sequences. Here, this DFT can also be obtained by sampling one period of this DTFT. DTFT is nothing but Discrete Time Fourier Transform. So we can define this DFT as equally spaced frequency samples of this DTFT. DFT of the finite duration sequence x of n is represented as x of k. For capital X represents the frequency domain signal or the frequency transformed signal. Here the small k represents the frequency index. So x of k, that is DFT of the finite sequence, is expressed as summation n is equal to 0 to n minus 1 x of n e power minus j2 pi kn by capital N. Here the small n represents the time index of the given signal. It is ranging from 0 to capital N minus 1. The small k represents the frequency index of this frequency transformed signal. So here it is also ranging from 0 to n minus 1. So what about this capital N? This capital N is nothing but the number of samples taken over the period of DTFT. So here we have taken the n equally spaced frequency samples of the DTFT. So here capital N represents the number of samples taken over the period of DTFT. So here that the discrete Fourier transform can also be expressed with this Twiddle factor. So here x of k can also be written as summation n is equal to 0 to n minus 1 x of n wn capital N to nk, where this wn represents e power minus j2 pi by capital N. So this is called as Twiddle factor. This is very important factor used in the discrete Fourier transform. Now we will see inverse discrete Fourier transform. Inverse discrete Fourier transform, that is IDFT, is mainly used to obtain the time domain signal from the transform signal. So here we can obtain x of n from x of k using IDFT. The expression for this inverse discrete Fourier transform is x of n is equal to 1 by capital N summation k is equal to 0 to n minus 1 x of k e power plus j2 pi kn by capital N. Here the frequency index is ranging from 0 to n minus 1. DFT pair can be expressed like this because we can obtain the Fourier transform, the value from this x of n using DFT. Similarly, we can obtain the time domain signal from this Fourier transform, this signal using IDFT. So this is called as a DFT pair. Here we can write the expression for both discrete Fourier transform and inverse discrete Fourier transform. So this is what the discrete Fourier transform pair. DFT is powerful computational tool used to analyze the linear time invariant discrete time systems. DFT can also be used in spectral analysis of the digital signals, especially on digital computers. So in the next video, we are going to see the properties of DFT.